Hello guys, welcome back. In the previous video, we have seen the first approach to find sum of digits until sum is single digit. So what is the time complexity for that respect to one we have seen? So time complexity would be order of log based on of n. So this is the time complexity for that. So in this video, now let's try to optimize our logic a bit. So now what exactly we have done in our previous video? So 1, 2, 3, 4, 5, sum is 15. So again 15, 1 plus 5 to 6. Let's try to observe the last example. So if you observe here, 892. So first 892 getting the answer to be 19. So next 19 to be 10, again 10 to be 1. So now what I'll try to do over here is, first I'll take the value 892 example. So here, what shall I'll try to do? So whenever you are trying to add the value, so whenever my sum is greater than 9, let's say first, what would you get the sum? Sum would be 2. So next, if you try to add the value 9 to that, so what would be your sum? So the sum would be 11. So now here I came to know that my sum is a double digit number. So when I came across my sum, which is a double digit number, at that respect to moment itself, I'll try to add these two numbers. So how do you try to add these two digits? So now what I'll try to exactly do is, so in 11, if I want to get the last digit, I'll be going with, so 11 modulus 10. Again, in the same way, if I want to remove the last digit from that, so then what I would do, I would do 11 divided by 10. So in any double digit number, if you want to get the last digit, you go modulus 10. And if you want to get the first digit, you go divide by 10. So maybe if I take the example 17, let's say. So here 17 divided by 10. So you get the value to 1. Similarly, 17 modulus 10, you get the value to be 7. So now what is my approach over here is, so whenever I find my sum to be two digits, so which is greater than 9, so there itself I'll try to add those two values. Now let's try to decode for the example 892 and understand. So if I take the value 892 over here, so first we are getting sum to be 2. So next sum would be, so 2 plus 9. So which is the value 11. So if you observe here, 11 is greater than 9. As it is greater than 9, what I would do, I'll convert these two values to 1 plus 1. So which is the value to be 2. So now our sum value is 2. So 2 plus 8 we are supposed to do, which is a leftover digit. So 2 plus 8, we are getting the answer to be 10. So again, now 10 is greater than 9. So what I would do, 1 plus 0 equals to 1. So 10 would be, so 1 plus 0. So which is the answer to be 1. So this is how we work, guys. So let's try to write the same code in our Visual Studio and try to observe. So before that, let me try to comment out this code. All right. So let's take our sum value to 0. Now what we'll do, same steps while number greater than 0. Sum would be incremented with number modulus 10, which is our reminder. And each and every time you remove the last digit. So whenever you try to find your sum is greater than 9, what you are supposed to do, you are supposed to add the first digit as well as the last digit. So how would you get the first digit? So when you divide by 10, you get the first digit. Similarly, how would you get last? When you do modulus 10, you get that respective value. So now these two, after addition, we need to store it to our sum only. So sum would be, so sum by 10 plus sum modulus 10. So once at last, if you go, just print our sum once you are done with your while loop failed. So let's run this. So taking the value 1, 2, 3, 4, 5, got the output to 6. So let's take the value 1, 2, 3, 4, got the output to 1. So let's also try to take the value 892. Still the answer is 1. So maybe if we consider one of our previous example, so here we got the answer to be 3. So let's run this. So let me give the same value. Still we got the answer to be 3. So if you observe, what is the time complexity of this program? The time complexity of this program is still the same. So why? Because we are dividing by 10. So but what exactly we have optimized over here is, so if I take the example 892 for the first approach, so after 892 you have done for 19. So after 19 is done, you have done for 10. So after 10 is done, you went for the value 1. So in this case, what exactly we have done, for the first time iteration only, we got all the outputs. So that's the beauty of this time complexity over this program. So that's all for this video, guys. Thanks for watching. See you guys in the next one.